Hello everyone. So today we are going to talk about the lipid transportation. So we will talk the detail about lipid transportation, the metabolism of the chylomicrons, metabolism of the various uh, lipid that we get from the diet and the cholesterol that we get from the diet. We'll talk about the detail about the lipid transportation and the proper lipid metabolism in this video. So before starting this video, I want you to know the key enzymes in the lipid transportation, the major apolipoprotein and the lipoprotein. So these are the three topics that you should know before starting the lipid transportation. So without the concept of the these three topics, so without the concept of the key enzymes in the lipid transportation, the apolipoproteins and the lipoproteins, you will not understand the lipid transportation. So you must know the key enzymes in the lipid transportation, major apolipoproteins and their function, and the lipoprotein and their function. So these three topics that you should know. I have already discussed these three topics in my previous video. So if you haven't seen my previous video, I want you to go and see that video, or you can learn from the any textbook, or you can learn from your previous note if you have. So I'm just going to revise those three topics. So the key enzymes in the lipid transport are the cholesterol ester transport protein that mediates transport of cholesterol ester to other lipoprotein particles, and the hepatic lipase degrades the triglyceride remaining in the intermediate density lipoprotein. The hormone sensitive lipase degrades triglyceride stored in the adipocytes. The lecithin cholesterol SL transferase catalyzes esterification of two-thirds of plasma cholesterol. The lipoprotein lipase degrades triglyceride in the circulating chylomicrons. The pancreatic lipase degrades dietary triglycerol in the small intestine. The PCSK9 degrades low density lipoprotein receptor, thereby increasing the serum LDL. It also inhibits the LDL recycling, thereby increasing the LDL receptor recycling, leading to decreased serum LDL. So PSK9 inhibition will increase the LDL receptor recycling, which eventually will decrease the serum LDL. And also the major apolipoprotein are apolipoprotein E, A1, C2, B48 and B100. So these are the major apolipoprotein. So apolipoprotein are the protein component of the lipoprotein. So the chylomicrons have apolipoprotein E, apolipoprotein C2 and apolipoprotein B8. Whereas the chylomicron remnant have the apolipoprotein E and apolipoprotein B48. The very low density lipoprotein has apolipoprotein E and C2, whereas the intermediate density lipoprotein has the apolipoprotein E, apolipoprotein C2 and apolipoprotein B100. The low density lipoprotein has only the apolipoprotein B100, whereas the high density lipoprotein has the apolipoprotein E, A1 and C2. You also need to know about the different lipoproteins. The lipoprotein chylomicron, VLDL, intermediate density lipoprotein, low density lipoprotein and high density lipoprotein has their own role. The chylomicron delivers dietary triglyceride to peripheral tissue. The very low density lipoprotein delivers hepatic triglyceride to peripheral tissue. The intermediate density lipoprotein delivers triglyceride and cholesterol to liver. The low density lipoprotein delivers hepatic cholesterol to peripheral tissue, whereas the high density lipoprotein mediates reverse cholesterol transport from the peripheral tissues to liver. So these three are some brief revision I have done about the key enzymes of the lipid transportation, the apolipoprotein and the lipoprotein, their functions, and the brief introduction I have done. If you want to learn more detail about those topics, you have to see my previous video, or you can read from the any textbook you have. So without knowing this, without knowing these enzymes, without knowing the apolipoproteins or without knowing the lipoproteins, you will not understand the lipid transportation. So I request you to read those three topics in detail. So now let's start our lipid transportation. So we are getting fat, right? So we have the dietary fat and cholesterol synthesis. So this dietary fat and cholesterol are converted into micelle form. Micelle are the small forms of the dietary fat and cholesterol that will secreted from the broad border of the intestinal cell, which is present in the lumen, will be taken up by the intestinal cell. So intestinal cell will take the micelles that is present in the lumen of the intestine. So this chylomicron, will enter the lymphatics. So it will enter the lymphatics. So after entering the lymphatics, you know that the thoracic ducts end in the subclavian vein. So it will get circulated in the subclavian vein, and eventually from the subclavian vein it will go into the systemic circulation. So this chylomicron that is secreted by the intestinal cell is nascent chylomicron. The nascent chylomicron means new chylomicron. It has triglyceride and ApoB48. So this nascent chylomicron will ultimately be converted into proper chylomicron. So here the high density lipoprotein helps. The high density lipoprotein has ApoB, ApoC2 and ApoE. So this ApoC2 and ApoE will be transferred to this nascent chylomicron. So in the nascent chylomicron we have ApoB48, ApoC2 and ApoE. That means apolipoprotein E, apolipoprotein C2 and apolipoprotein B3. So all this apolipoprotein, when attached to the nascent chylomicron, it will be converted into the proper chylomicron, that is mature chylomicron, that is chylomicron. So this chylomicron upon the action of the lipoprotein lipase that is present on our systemic circulation. What happens? The nascent chylomicron will be acted by the lipoprotein lipase. So the lipoprotein lipase degrades triglyceride in the circulating chylomicron. So what happens? The lipoprotein lipase will decrease the triglyceride and it will cleave the ApoC. That means it will cleave the apolipoprotein C2 and it will be entered into the adipocyte, converting into triglyceride and free fatty acid. So we have the chylomicron that doesn't have ApoC. The ApoC2 is cleaved off. And now we have the remnant of the chylomicron. What is the remnant of the chylomicron? The remnant of the chylomicron has only ApoE and apolipoprotein C2. So with the help of ApoE receptor, that ApoE mediates the remnant uptake of the chylomicron. So ApoE receptor will mediate the uptake of the remaining chylomicron in the hepatocyte. So this remaining chylomicron will be taken inside by the hepatocytes. So this is how the hepatocyte mediates the uptake of the remaining chylomicron. So we have the cholesterol and triglyceride in the hepatocyte, and the hepatocyte will secrete the nascent very low density lipoprotein. The nascent very low density lipoprotein has triglyceride and cholesterol and the apolipoprotein B100. So upon the action of the high density lipoprotein on the nascent VLDL, the VLDL now will have ApoB100 and ApoE and apolipoprotein C2. So the nascent VLDL with ApoB100 and apolipoprotein E and apolipoprotein C2, it is called the proper very low density lipoprotein. So again, this very low density lipoprotein will be acted by the lipoprotein lipase and it will be taken up by the adipocytes. So in this step, the VLDL apoprotein C2 activates the lipoprotein lipase and this will be taken up by the adipocytes. So now, when action by the lipoprotein lipase, the ApoC2 will be cleaved off by this very low density lipoprotein, and there will be decrease in the triglyceride level in this very low density lipoprotein. Now, the very low density lipoprotein without the apolipoprotein C2 and decreased amount of the triglyceride is known as intermediate density lipoprotein. So this intermediate density lipoprotein will be acted by the hepatic lipase and it will be converted into the low density lipoprotein. So this apolipoprotein E will also be cleaved off and the content of the triglyceride will also be decreased, thereby it is the low density lipoprotein. It will be converted into the low density lipoprotein. So ultimately the low density lipoprotein will be taken by the peripheral cell by the endocytosis. The peripheral cell has the low density lipoprotein receptor and the low density lipoprotein will eventually be taken by the peripheral cells. So this sums up our lipid transportation and the lipid metabolism, dietary fat and cholesterol metabolism, how the various organs helps in this lipid transportation, the action of the various lipid enzymes, various enzymes that help in the lipid transport, the help of the apolipoproteins and the chylomicrons help in the lipid transportation. So I hope you understood this lecture. So this sums up our video on the lipid transportation. Thank you.